Hello, in this session I'm going to work some problems in Chapter 8 and go through them in some detail so you can see what my logic is as far as solving these problems. The first problem is problem 8.5, and it states, a company that sells reverse osmosis water purifiers has the following fixed and variable cost components for its product over a 1-year period. Determine the revenue per unit required to break even if the sales volume is estimated to be 5,000 units, and that would be units per year. Because this is over a 1-year period, so everything is per year. So we'll assume that's per year as well. Okay. So the question is, how much do you need to break even? How much in terms of revenue per unit? The following fixed and variable costs. So we have all our cost, and we have our volume quantity, but we don't know how much revenue per unit. What determined the revenue required per unit? So in our symbols, that is little r equals question mark. And remember, the break-even point is where break-even volume or quantity is where total revenue equals total cost. Okay. Well, the total revenue is simply R times Q, which in this case is 5,000 units per year. Everything is per year, but R is not known. So that's the total revenue. That has to be equal to the total cost. Well, if we add up all of our fixed cost, which is the left-hand column, we get $100,000. Well, total cost, recall, total cost equals fixed costs plus the variable cost per unit times the number of units, Q. So this is going to be 100,000. That's the fixed cost. And if you add up the variable cost, they come out to $33 a unit. So this is going to be plus $33 per unit times Q units. Okay. So, but Q is 5,000. So this is equal to 100,000 plus 33 times 5,000. And these are dollars. These are going to be dollars because it's dollars per unit times units. The units cancel. We'll get dollars. So this is dollars and this is dollars. And now if we look at our right-hand side, this is R times 5,000. If we divide through both sides of the equation by 5,000, we'll get R isolated, which is what we're looking for. R is equal to 100,000 divided by 5,000 plus 33 times 5,000 divided by 5,000. So these 5,000s will cancel, and this 100,000 becomes divided by 5. 100 divided by 5 is 20. So 100,000 divided by 5 is 20 plus 33. That gives us $53 per unit. That must be our revenue per unit in order to break even if we sell 5,000 units. So that is the end of problem 8.5, and we'll go on to our next problem. The next problem I'm going to work is problem 8.26, or problem 26 in chapter 8. And it says, determine the payback period at an interest rate of 8% for an asset that has an initial cost of $28,000. So let's stop there and put what we're looking for. N sub P, which is the symbol we use for the number of periods to pay back. N sub P is the question mark. I is equal to 8%, and P is equal to minus 28,000. It has a salvage value of $1,500, so that'll be an F equals $1,500. And whenever it is sold, and generates cash flow. So this future salvage value, no matter when it's sold, it'll be $1,500, and it generates cash flow of $2,900 per year. So that's a uniform series. A is equal to $2,900 per year. Everything else is dollars. That's dollars. That's dollars. And of course, that's going to be number of years because that's per year. So the first part, it says use the interest factors to find the break-even point. Determine the payback period. So the payback period, N sub P, is where the revenue equals the investment cost. So our investment cost is $28,000, and we want to then set that equal to our revenue. Well, we get $2,900 per year, and so we need to bring that to the present time. So this is where the present value of the initial cost equals the present value of the revenue, which is $2,900 times P given A, 8% for this unknown number of periods, N sub P. The other element of revenue is simply the salvage value. So that's $1,500, and that's a one-time pay. So that's P given F at 8% for NP, periods. So to do this using the interest factors, you just have to guess an NP value and look at it and go from there. Well, I know that when you bring things back to the present, they shrink. And so, for example, if you brought this back to the present, it would certainly be less than say I guessed N equal 10. This would be less than 2,900, and much less, quite a bit less. So, but I'm just going to go ahead and say guess NP equals 10. Okay, let's see what happens then. We'll have 2,800 equals 2,900, P given A, 8% for 10 years, plus 1,500, P given F, 8 and 10. And if we crank through that, this quantity here, using the app, I got $19,459, and using the app on this one, I got $695. So when I added these two together, I got 20,154. Well, that's not nearly 28,000. So N so N is too small. I need to bring back more years to get to 28,000. Okay. So I said, okay, well that was way too small. So let's try let me guess, NP equals 20. Okay, so then I'll have 28,000 equals 2,900, P given A, 8% for 20 periods, plus the salvage value, 1,500, P given F, 8% for 20 periods. When I crank through that, this quantity here turns out to be 28,473, and this 1,500, when I bring it back for 20 years at 8%, shrinks all the way down to $322. So the sum of these turns out to be 28,795. That's a little too big, and is too big by just a little. So what's my next guess? I'm going to guess n equals 19. NP equals 19 for my third guess. This is my second guess. This was my first guess. Here. And this is going to be my third guess. And then I have 28,000 on the left side equals 2,900, P given A, 8% for 19 periods, plus 1,500, P given F, 8% for 19 periods. And I crank through that, I get 27,850 for this quantity. And then this quantity here is going to be a little bit bigger than that, right? So it turns out to be $348. And when I add these two together, I get 28,198, which is still a little bit too big, but I'm going to declare 19 close enough. So actually, the actual number NP will be between 18 and 19, but it'll be pretty close to 19. And sometimes we, on the number of years, we just round it up anyway. So I'm gonna say the answer is 19. Okay, and go for that for Part A. Part B, it says to use the spreadsheet function to calculate your actual value. So in the spreadsheet function, we have a function, let me write this here, Part B. We have a function, if we put in equal NPER, which is number of periods, open parentheses, it's going to ask us for the interest rate. I put in 8%. The next thing it's going to ask you for is, if you have a uniform series, an A value. And sure enough, we do, 2,900. The next thing it'll ask you for is the present value. Well, the present value is that minus 28,000. So I put in minus 28,000. And then it asks you for the future value, and that's that salvage value, 1,500. And if you put that in, it will display the value. Excel displays NP equals 18.7 years. So that's the exact value of NP. My trial and error method, I just quit at 19. Either one of those would be a correct answer. And that finishes this problem. We'll go on to one more problem. Problem 839 says, your dad made the following estimates as he considered upgrading the air conditioning system in their home. Use the annual worth analysis to determine the sensitivity of the economic decision to the interest rates of 4, 6, and 8% per year. So our variable that we're not sure of, we're going to calculate it for several different values of that variable, is the I value. Now, he has data on these two systems, and what we're going to do is we're going to have to calculate the annual worth of System 1, the annual worth, I'll call it AW1, and the annual worth of System 2, AW2, for I equal 4, and then we'll go do that again for I equals 6 and for I equal 8. And understand, by the way, if you look at the data, this is the first cost, annual operating cost, salvage value. It actually has a negative salvage value. Costs you money to get rid of it. A new compressor at midlife, it says. So this one has a life of 8 years. So that would be, this number here will occur at 4 years. This one has a life of 12 years. Well, we cannot compare two systems that have different lives. So what do we have to do? We use the least common multiple of lives. We say, we'll repeat this one 2 times to get a total of 3 cycles and get me to 24 years. We'll repeat this one once to get a total of 2 cycles, and this will end at 24 years. So that's what we'll do. But we don't have to do cycles 2 and 3 or whatever. We only have to do is the annual cost for this system over 8 years, the annual cost of this system over 12 years, and we know that annual cost will be repeated as many cycles as we repeat. So we're just going to have to do 1 cycle of each system. And so let's write the equation for the annual cost at, I'll say I equal 4%, okay? So what's the annual cost of System 1? AW at 4% of 1, System 1 equals. We've got a first cost of $100,000. I'm sorry, $10,000. So these are nothing but cost. So I could even drop the negative sign. So I'll have $10,000. That's a P. A given P, 4% for 8 years. That will spread this over 8 years evenly. Annual operating cost is $600, and the salvage value, well, we'll have to put the $600 here. That's the dollars. But this is a salvage value that occurs at time 8. So we need to bring this and spread it back over the 8 years. I'll just do it A given F. So that's minus 100, A given F, 4% for 8 years. But this one occurs at the end of year 4. That's the midlife of this system. So I will have to bring that back to the present as a single payment, P given F, 4% for 4 years. Now I have a present value. Spread that over 8 years. A given P, 4%, 8 years. So that's the equation at 4% for System 1. Let's look at System 2. The annual worth of 2 at 4% will be, that system costs $17,000, but it's going to last 12 years. So we'll spread that $17,000 over 12 years at 4%. So it's A given P, 4 and 12. And this is an annual amount minus 150. And then this is a salvage value, but that would occur at time 12. So that's minus 100, A given F, 4% for 12 years. And then finally, we have this mid-year compressor change out of $3,000 at year 6. Mid-year is year 6 on this system, so it's going to be minus $3,000. Bring it back to the present, P given F, 4% for 6 years, and then take that and spread it over the 12 years at 4%. So that's the equation for the second term. And then we're going to have to calculate this value, and then we'll do that again. We'll do these same two equations, only we'll change the rate to 6% and change the rate to 8%. And I've shown you what results you get when you do that in the next page. For example, at 4%, this is going to end up being minus 2318. And system 2 will be minus 2234. All of the numbers were negative, remember. Well, I better put the negative. That's negative, that's negative. Okay. And the lower of those two costs then is this one. If you go to 6%, so the better solution at 4% is system 2. But if you go to 4%, I'm sorry, to 6%, then this one is minus 2,444 a year. This one's 2,448. So system 1 is the better one. And then at 8%, system 1 again. So the decision does change, and it changes somewhere between 4% and 6%. So you basically have a graph that would look like this. If you have, this would be the rate, I, that's the variable, and this is, say, 4%, 6%, 8%, and this is the annual worth. If we look at system 1 and plot it, we have minus 2318. So I don't know how to make this to scale, so to speak. 2318, and this is negative. This is going in the negative direction. Okay, and then then it goes up to 2444. At 6%, and then at 8%, it goes up to 2573. And so that is system 1. And system 2 starts, the first one is a little bit higher at 4%, okay, 2234. Let me do that in red. It's a little higher, I'm sorry, it's lower. What am I talking about? 2234. This is system 2. But then this one is just barely higher, 2448 at 6%, and then at 8% it's quite a bit higher. It's up here at 2673. So that's system 2, and it goes like this. So it has a steeper slope than system 1. System 1 was like this. And they cross somewhere here between 4 and 6%. So that would be kind of a visualization of what's going on there. And that'll conclude my little problem session. Thank you.